We're given three functions and asked to determine whether or not they are even or odd or neither. And so we're going to look at how we can algebraically tell that answer and how we can come up with the answer graphically. So starting with the first function, f of x equals x squared plus 1, if we were to substitute in negative x into our equation, we would have negative x squared plus 1. And a negative times a negative is positive, so we end up with x squared plus 1. Now note, this is the same thing that we started with. That means that we have an even function. An even function is defined to be a function in which f of negative x is the same thing as f of x. Now, if using variables confuses you, you could also do this with numbers. For example, if you were to plug 2 into this equation, you would have 2 squared plus 1. 4 plus 1 is 5. If you were to substitute in negative 2, negative 2 squared plus 1, negative 2 squared is 4, 4 plus 1 is 5. You got equal answers. When you get equal answers, when you plug in a positive and a negative, then the answer is even. Graphically, if we look at the graph of this function, this is a parabola that's shifted up 1. So its graph would look something like this. Notice that if you were to take the right half of the graph and reflect it across the y-axis, you would get the same thing on the left side. Whenever you have a function that is symmetric to the y-axis, then you know that you have an even function. So graphically, I can tell that this function is even because it's symmetric to the y-axis. In the second example, we have f of x equals x cubed minus x. If we substitute in a negative x, we'll have negative x cubed minus negative x. Negative x times negative x times negative x is a negative number, so that's going to equal negative x cubed. Minus a negative x would be plus x. And so when we compare this answer with what we started with, we have the opposite of each term. Whenever we end up with the opposite of everything that we started with, then we have what is called an odd function. The definition of an odd function is when we substitute in a negative number, we get the opposite of what we get when we substitute in a positive number. Now you could also go back and check this out with just a number if you prefer. If we were to find f of 2, we would have 2 cubed minus 2. 2 cubed is 8. 8 minus 2 is 6. If we substitute in negative 2, negative 2 cubed minus negative 2. Negative 2 cubed is negative 8. Minus a negative 2 would be plus 2. And we get negative 6. So we got the opposite of what we started with. When you substitute in a negative number and you get the opposite answer from when you substitute in a positive number, that means that it is indeed an odd function. If you were to look at the graph for this particular function, we have something that looks something like this. And notice that this function is symmetric to the origin. If we were to rotate the graph 180 degrees, we end up with the same thing as what we started with. Another way to think about things that are symmetric to the origin is if you reflected them across the y-axis and then over the x-axis, you would end up right back where you started. Functions that are symmetric to the origin are odd functions. So graphically, we can tell that the function is odd. On our third example, if we substitute in a negative x, we have 2 times negative x squared minus 4 times negative x plus 3. Negative x, when you square it, is positive, so we end up with 2x squared minus 4 times negative x would be plus 4x plus 3. And so if we compare this with what we started with, we don't have the same thing, so it's not even, and we don't have opposites of each term, so it's not odd. So this particular function is neither. If you like to work the problem by substituting in a number, let's consider if you substituted in 2, we would have 2 times 2 squared minus 4 times 2 plus 3. 2 squared is 4, 4 times 2 is 8, minus 4 times 2 is 8, plus 3, so we would end up with 3. If we enter a negative 2, we would have 2 times negative 2 squared minus 4 times negative 2 plus 3. Negative 2 squared is 4, 4 times 2 is 8, but minus 4 times negative 2 would be plus 8 plus 3. And so we would end up with 16 plus 3, which is 19. So we didn't get the opposite thing, we didn't get the exact same thing, and therefore our function is neither. If you go back and you look at this graph, you end up with a parabola that has a vertex at about 1, 2. And I can see that this function is not symmetric to the origin, it's not symmetric to the y-axis, so from the graph I can tell that this is neither even or odd.